In this video, we'll be discussing box plots. A very simplified definition of box plots is that this is a method for graphically depicting groups of numerical data through their quartiles. So that's the important sort of feature of box plots, right? They're all based off of quartiles. They have other names, right? You hear box plots, you'll hear box and whisker plots or box whisker plots. But the idea behind them is they really give us a good representation of where data are concentrated in a particular data set. The other use of box plots is that you can see just how far extreme values are from most of the data. They just give us a really good picture of what's going on in our data set. The box plot is constructed from 5 values, and the first one is the minimum. Okay, so we have the minimum value, the first quartile, the second quartile, also referred to as the median, the third quartile, and then the maximum value. And so this is a depiction of a box plot, and I'm just going to put in what each of these components of the box plot are. So the over here, this mark right here denotes the minimum value. This right here denotes Q1. This bar here is Q2, the median. This is Q3. And then you may have guessed this is the maximum value. So typically, you can be presented with both scenarios. The first one being you have a data set and you need to build a box plot. If you have a data set and you have to build a box plot, it's up to you. Go find the min, calculate Q1, calculate Q2, Q3, find the max, and you use those values to build the box plot. On the other side, you may be given a box plot and you have to interpret sort of what's going on here. So if I look at this box plot, I can see that my minimum value is 1. Okay, so often the set of values you need, you summarize very succinctly like this. Okay, so I can see my minimum value in this case is 1. My Q1 looks like it's at 2. Make these equals. My Q2 looks like it's at 7. My Q3 is at 9. And my max, it looks like 11.5. Right, I can read these values right off here. There's my maximum value, right? So there's my max, my Q3, my Q2, my Q1, and my min. So one of the features of box plots is that the middle 50% of the data, so think about the middle 50% of the data, right? That's Q2 and Q3, what's in Q2 and Q3, fall inside the box. The whisker component is basically just sort of giving you a good picture of outside that 50%. What is my smallest, what is my largest data value? So the data set that we used to generate this box plot in the previous slide and in this slide, this is what the data looked like. Okay, so you can see here's the minimum value of 1. Q2 is the median, which is at 7. Now notice 7's not in my data set, is it? I have a 6.8, I have a 7.2, but the median is right in between there. Q3 is 9, so this looks like Q3 right here. And my max value is always the last one. So from these Q1, Q2, Q3, min value, max value, I can build a box plot. What I'd like you to do is try and build one based on this data set. This data are the heights in inches of 40 students in a statistics class. So it starts at 59 inches, and I'm looking across the data, and it looks like it's already ordered. One quick note, okay, so you always have to have data in order. And if it's not, you have to put it in order. Have data in order, least to greatest. Because remember, quartile is a position, right? What data is in the position, you know, that we're, for example, the Q1, which is the 25th percentile. What, you know, it's the data at that position. And so in order for the position to make sense, the data has to be in order. So take a minute, pause this video, and take a minute to draw your box plot. And now here we have two different solutions. Because when you might have struggled this when you tried drawing this on your own, you have to figure out what's my axis going to look like? How am I going to label my numbers? Here in this case, I decided because I go from 59 to 70, to 77, that I'm going to make my data go by 2. So I'm going to start at 58 because I have to be below my minimum just so I have a little space. And I need to be above my minimum. So I went by 2s on this axis, and that's what my graph looks like. On this one, solution 2, I decided I'm going to go by 5s. And so I started at 55 because I want to start below my minimum. So 55, 60, 65, 70, 75, 80. And if you look at these two box plots, you can see the shapes are the same, right? I can interpret each of them, and I should have the same interpretation. They're, I personally maybe like this one a little bit better because there's a little more detail, but the one below is just as good.